Welcome to Software Testing from Scratch, brought to you by Eduonix. My name is Richard Martin, and this is just an introduction to the course. So the syllabus we're going to be covering is Introduction and Overview, what to test and how to test it, the phases of testing, approaches to testing, non-functional testing, platform specialization, test automation, behavior-driven and test-driven development, and of course the all-important report writing and sign-off. So in this video we're going to cover why do we test software and what happens when we don't, where does the term bug come from, the purpose of testing, and the software testing lifecycle. So why do we test software and what happens when we don't? This was one of the most expensive examples I could find in the press. I'll just read it out to you. The clothing manufacturer Levi Strauss in 2003 was a global corporation with operations in more than 110 countries, but with an IT system that was very out of date, shall we say. It had a mix of incompatible country-specific systems, so its bosses decided to migrate to a single SAP system and hired a team of consultants to lead the effort. Fantastic idea. The risk seemed small, wrote the researchers. The proposal budget was less than $5 million, but very quickly things started to fall apart. One of the major customers, Walmart, or Asda in the UK, required that the system interface with its supply chain management system. Of course he'd wanted to. This would also create additional work during the change, but during the switch over to the new system, Levi Strauss was unable to fulfill orders and had to close 3 US distribution centers for a week. In 2008, the company took a $192.5 million fine against earnings to compensate for the botched projects, and it fired its chief information officer. Now that fine wasn't just covering losses, it was payments to its customers for compensation, mainly just for the orders that the words weren't supposed to fulfill, but they also didn't comply with certain testing regulations, so it also paid legal fees for that as well. Now, where does the term bug come from? There's various examples online, however this seems to be the one that everybody goes for. The first computer bug was discovered by Grace Murray Hopper at Harvard University in 1945. She had a Mark II Aiken calculator, which, for those of you who don't know, is probably about the same size as a 3-bedroom house, and it is just a calculator. It was experiencing some issues. Upon further investigation, a moth was found between the contacts of the relays. Indeed, the first bug was a real one. For further proof, the moth was removed and added to a logbook with an entry reading, "First actual case of a bug being found." The logbook with the moth can be found at the History of American Technology Museum, which is part of the Smithsonian. Wow, I'm not sure I'd want to go all the way to America to look at a moth sellotaped to a test report, but then again, those of you who want to, it is there to see. In my opinion, that's where the term bug came from. Feel free to Google it. There are some other ones up there, but this seems to be the most convincing. So the purpose of testing. Testing accomplishes a variety of things, but most importantly, it measures the quality of the software you're developing. This view presupposes there are defects in your software waiting to be discovered, and this view is rarely disproved or even disputed. There's probably going to be a bug in every bit of software you'll look at. The severity of which may not be that it stands out, but you can guarantee there'll be a bug there somewhere. So reducing the cost of developing a program. Minimal savings that might occur in the early stages of the development cycle by delaying testing efforts are almost certainly bound to increase development costs later on. Common estimates indicate that a problem that goes undetected and unfixed until a program is actually in operation can be anywhere between 40 and 100 times more expensive to resolve rather than resolving the problem early in the development life cycle. Ensuring that your application behaves exactly as you explain to the user is also a major purpose of software testing. For the vast majority of programs, unpredictability is the least desirable consequence of using an application. Also, reducing the total cost of ownership by providing software that looks and behaves as shown in your documentation. Your customers require a few hours of training and less support from product experts later in the day. Developing customer loyalty by word of mouth also helps increase your market share. I know a few people who have their own startup companies and they only ever get business via word of mouth, which is a fantastic way to do things. Finding success with a program that offers the kind of quality that only thorough testing can provide is much easier than trying to build a customer base on a buggy, defect-riddled bit of code. Now, your fundamentals to software testing are definitely the key, especially for exams, but in the real world as well. The software testing lifecycle should be followed with every test case. Although you don't reference it, this is just the logical flow in which you do things. You have your requirements, you then perform your planning and your design, you then do your test execution and defect logging, and then your test reports and acceptance and sign off. But at the test execution and defect logging, chances are you would probably go back to test execution again after defects have been accepted and fixed. This ensures the process is of the type and quality needed and expected by the client or customer. Now, the requirements document is a specification that establishes the basis for an agreement between customers and contractors on what the software product is to do, as well as what is not expected to do. It should also provide a realistic basis for estimating product costs, risks, and schedules. A roadmap is a functional document that explains in detail how a change will be implemented. Because it's a roadmap or a blueprint, the document must be written and approved prior to any code being written by the developers. A software design document is written as a description of a software product that a software designer writes in order to give a software development team the overall guidance to the architecture of the software project. Use case document is a list of steps, typically defining interactions between a role in a system to achieve a goal. It's imperative to map test cases to real-world test cases or even events. This is where you put yourself in the shoes of your average user. Try and figure out what they're going to be doing on a daily basis and write tests around that to make sure it's all captured. Now, a test traceability matrix is the mapping between customer requirements and the prepared test cases by the QA team. It's used by the testing team to verify how much test coverage of requirements they have. So here we have requirements mapped against test cases. Requirement 1.1, the color will be blue. Test case 1.1, verify the color is blue. Requirement 1.2, the flavor will be orange. Test case 1.2, verify the flavor is orange. Perfect. Now, the testing scope. In the scope section of the test plan, the test team describes specifically what you want your testing to accomplish. For example, the objective of one team may be to migrate an NT4 server to a Windows 2003 environment, component by component, keeping the access control list and exchange permissions intact. Anything else apart from those two requirements is out of scope, and you can't be expected to test that. And it also means that if it doesn't work, there's no comeback on yourself or the QA team either, which is what you want. Now, the test environment. Sometimes you'll be lucky enough to have your own copy of the production system. Ideally, it will be an exact copy for you to do some exploratory testing first without affecting the live service. It's usually not even on the same physical network. In reality, it's probably going to be a cut-down version, but it should still replicate as close as it can to the production system to make sure your test cases are very accurate. Now, the testing phases, we have the analysis phase, the design phase, development, execution, retest and regression, and implementation.